energy the basis for our modern life. But the demand is growing worldwide, both at work and at home. For leisure and mobility, we are consuming more and more precious energy resources. Renewable energies are still not capable of replacing fossil fuels. Yet coal, oil, and natural gas are only available to a limited extent and are becoming more and more expensive. And when they're burned to generate electricity and heat, the power plants emit carbon dioxide, with catastrophic impacts on the climate and the environment. In order to prevent this greenhouse effect, we have to utilize the available raw materials more intelligently and avoid unnecessary waste. During conventional power generation, about 38% of the energy utilized is converted into electricity. The rest is released unused into the air, where it's irretrievably lost. Likewise with the separate generation of heat. With an oil-based central heating system, for instance, yet another new source of energy has to be burnt as fuel. And that certainly is not effective, by far. Plants that co-generate heat and power, like the Berlin-Mitte gas and steam turbine power plant here, are able to combine these two processes. They extract the heat which is produced during electricity generation and reutilize it as thermal heat or warm water. CHP, as combined heat and power is called, converts the fuel utilized into energy at a rate of up to 90%. This means that in comparison to conventional separate generation of heat and electricity, CHP plants save up to 40% of the primary energy utilized and achieve a significant reduction in CO2 emissions as a result. How we manage to conserve our resources represents one of the greatest challenges of the future, and the time to start using energy efficiently is now. CHP is suitable for use with petrol and gas engines, in gas turbines, as well as with innovative drive technologies such as the Stirling engine, steam turbines, or fuel cells. And while natural gas and oil are the common fuels used to date, renewable energies such as biogas, for example, can also power combined heat and power units. CHP units are compact and generate electricity and heat very close to the consumers. In this way, energy losses caused by long pipeline systems can be eliminated. And that's not only economical, it's also good for the environment.
This is our fuel container which supplies the wood gasification plant with biomass. As biomass, we use G50, which contains wood chips coming from the surrounding area of the plant. The biomass is transported to the gasification process by using screw conveyors. The gasification process is divided into 4 stages: drying, pyrolysis, oxidation, reduction. We're talking about temperatures above 1000 degrees here, so that we can break long-chain hydrocarbons. By doing so, we reduce the amount of tar in the gas. At the bottom of the gasifier, the ash accumulates and is then discharged into an ash container if the plant is stopped. After going through the cyclone, the 320 to 400 degrees hot gas passes through to a heat exchanger in the rear region, where the gas is cooled down to 120 degrees. The cooled gas then moves into the fine filtration, which is this device you can see here. After passing the organic filter, the cleaned gas is fed into the CHP. The CHP is our own development and works with wood gas. A Kubota motor and an asynchronous generator with 22 kilowatts are used. We take the heat coming from the motor circuit, from the cooling water and the exhaust gas to heat our buildings, and the electricity is fed into the grid as green electricity. The entire system is fully automated. We have an industrial programmable controller, and the whole plant works like a heating system. We need 5,000 litres of buffer tank for our entire system. If the buffer tank cools down at the top, The system turns itself on, and within 200 to 300 seconds it works at full power. It then runs until the buffer tank is sufficiently supplied with heat, and then it turns itself off again. The first plant to start operating 4 years ago is located in Voitsberg, at the premises of the Kramer family, and this plant has already been in use for 11,000 operating hours. As an operator, you need to invest 1 to 2 hours a week so that the system runs smoothly, maybe a bit more time in the winter and less in the summer, as we're heat-driven. Part of the maintenance is that the cyclone, the filter and the ash bucket need to be empty. The aim is to make full use of the machine throughout the whole year.
In order ultimately to be able to produce clean gas, the organic waste must first be freed of all extraneous material. This equipment sifts out sand and stones. Then the other impurities are removed, such as plastic fragments, which regularly turn up in organic waste. What is left is a biosoup, the feedstock for gas production.
Vom Vorratsbehälter geht es in eine Hygienisierungsanlage.
From the holding tank it passes into a disinfection unit. Here the material is heated up to the regulatory 70 degrees for an hour. This serves to reduce pathogenic bacteria and thus rule out the survival of sources of disease in the material. It is the case that the end product of this biogas process is put to use in agriculture as a valuable fertilizer, but then it has to fulfill the corresponding quality criteria.
In diesen Reaktoren machen jetzt Milliarden von Mikroorganismen.
In these reactors, billions of microorganisms make biogas from the dissolved organic material. This biogas must now be separated from the liquid. This takes place through intensive mixing and stirring, and then being subjected to 3 stages of purification.
Man versucht jetzt, die Maschinen möglichst auch das ganze Jahr über auszulasten.
The aim is to make full use of the machine throughout the whole year. A central element in this process is the gas engine, which burns the biogas and produces electricity and heat. In order to allow a continuous operation of this engine, we strive to provide the biogas continuously. This means that also the biogas production process needs to be carried out continuously. This is tricky, as the working hours of the staff are discontinuous, that is to say, only from Monday to Friday.
Diskontinuierlich sind, das heißt nur von Montag bis Freitag in der Arbeitszeit stattfinden. Etwa 2/3 der Einkünfte des Umsatzes passieren durch die Übernahme von Abfällen.
Approximately 2/3 of the earnings come from taking over the waste. Each waste producer has to pay a fee, meaning that he needs to pay someone to collect his garbage. The waste treatment operator, in this case the biogas plant, gets a fee for receiving the waste. The remaining third of the earnings comes from the transformer, where the electricity is fed into the grid. Here the plant functions as a power plant and produces electricity as well as heat. And these energy sources are sold. The electricity produced is mainly fed into the grid, but it is also used to refuel a corporate e-vehicle.